Okay. Thanks everyone for coming. We have today Ryan and Michelle are going to talk about map making in R. There's actually a lot of different ways to do map making in R, and they're mostly going to talk about relatively new tools in this that let you use things like what exists out there in Google Maps and let you create interactive and like web accessible maps and things like that. Though both are fairly experienced in sort of the full set of tools in this. So there's sort of all of this traditional like shape and projection stuff too in the base packages. And so they're going to talk about that. Ryan is a graduate student in the GGE and has been at the Center for Watershed Sciences. Been a researcher at the center, and Michelle is at ICE, which is the Information Center for the Environment, which is sort of our GIS shop right here in ESP. So I guess Ryan will kick this off, and then Michelle will take it next. So let me just put Ryan's screen up.
Sweet.
And all right, is your audio going?
Can everybody hear me?
Yeah. Okay, I'm getting it.
Are you? Yeah. Okay. Great. Okay, so let's go ahead and get started. So I just wanted to talk a little bit about the just maps in general, and then I have a bunch of quick examples, mostly static maps, but I do have one dynamic map. And then Michelle's going to show Leaflet, which is a dynamic. It's actually a really cool package. It's sort of the next level up, I think, and it's really worth checking out. So anyway, I love Farside, and I think this is a good illustration of why maps matter. Sometimes it's a lot easier to draw a picture or provide something that gets the information across sometimes. So it's a good Friday morning cartoon. Anyway, so you want to display your data, you want to figure out relationships spatially, and sometimes it's just the easiest way to share data with people and make it accessible. And I think that ultimately is really one of the best things the things I'm going to show you what they do really well. So the idea is I'm going to show you a few methods to make spatial maps using just XY data, so lat longs. Largely, these all require your lat longs or whatever your spatial data to be in decimal degrees, just because that's what largely Google and a lot of these packages function on decimal degrees. So there's many ways to convert from UTM or things like that. I'm not really going to get into that today, but if you have questions about that, there's definitely packages and options that you can sort of convert your spatial data pretty easily. So the first package is a static Google Viz and ggmap. So the library I'm going to talk about is ggmap. And then these are using ggplot as well. So I pulled from USGS has a really cool data set of hot springs for California and Oregon. So I figured that'd be kind of fun to plot up. So basically the data looks like this, where you have a state, a lat along, the spring name, the temperature in Fahrenheit and Celsius. So some of them are really hot, others not so much. And it has some other data just on sort of the USGS's classifications, and then it gives a sort of the nearest NOAA station. So if you wanted to look up the weather at the nearest hot springs you want to visit, you can check it out. And then the USGS quad, 7.5 or 15-minute quad. And so you can see this has kind of weird formatting and stuff just in pulling in some of this data. So I had to just strip those odd E characters off the end. So I did that, and then I just pulled the columns that I was interested in using in the plots, which were the lat long, spring name, temperature, the weather station, and then the quad. So if you wanted to sort of look at any of that data, you could pretty quickly.
Is it possible to zoom in at all?
I don't know. Control plus. There we go. Great. Is that easier? Yeah. And I'll provide this all on the afterwards, so everybody can see the scripts, how this all works. So what's cool is this is pretty much a super easy way to get a map, and you basically tell it get map, and then the location. So you can set a lat long. This is just sort of centered in California. You tell it what zoom level you want, whether to crop it, sort of the scale. It'll auto scale, and then I wanted a color map and terrain. So in Google, you know, there's terrain, there's satellite, there's road map, I think, or something like that. So there's those three categories, and you can. The nice thing is you can specify what you want, and when I show the dynamic map, you'll be able to actually see you can turn those layers on and off as you like. So then it basically goes and gets a base map for that, and then you have to call this GG map to basically pull that in. So it's the first part is it's getting the base map. The second part is it's setting the extent of that map, and then all I'm doing is adding the points. So this is just geom point. So if you know ggplot, this is just ggplot, and it's basically the data frame, an x, a y, and then whatever you want to make it, however you want to make it look. And so the result is you get just a really nice, clean map. And you can obviously play around with these points as much as you like. You can change the underlying base map. So let me pull up a code for this. So we can see, so we wanted to do the same thing, but so let's make it satellite instead of. So I'm just going to change this to satellite. Think for a second and say, okay, we went and got the data, bring that in, and then plot it. And it takes a second. Oh, I have to print that. There you go. And so there you go. So it's pretty nice, pretty easy. And you can play to your heart's content, and you can change the zoom. So if you have data you want to really zoom in, you can actually, I mean, with a satellite imager, you can get in really close, which is nice if you have field sites and you kind of want to get a nice map of your field site. And then the other nice thing is then you can label, you can add all kinds of other spatial data to this, which is great. So this is really easy. This is the first one. Let's find. Okay, so moving on. So now let's talk about the dynamic one. This one is a little bit trickier, but not all that much. So this is using the Google Viz package, and essentially I'm going to use the same data set. The only difference is Google Maps uses a interesting where they have to paste the lat long has to be in the same column essentially, and they prefer this specific format where it's separated by a colon. So all I'm doing is just pasting the two columns together and then rounding to just to 3 decimals. So you end up with this lat long column. The next thing is that it has to be in the first column of your data set, just the way that it calls that data frame. So I just move lat long to the front and keep all the other data. Okay? And feel free if people have questions if I'm going too fast. Then this is the fun part. So now in Google, or Google Earth, you can click on a balloon and it'll bring up data, like a little pop-up of what you want people to see. So this is what you do to make that sort of, they call it the tip category. And so now I'm just pasting in sort of in this HTML format of what I want things to pop up as. And so I want the spring name, and so I give it a name, hot spring equals, and then the data. And then this $BR is just HTML for a break. So that's just saying next line. Otherwise, it'll make one long line and not very readable. So then just I go through each of the columns, basically, and make a new line between each and call that data. And then that's basically being pasted together as a character string in one single column, so the tip column. Then all you do is this GVIS map. You call your data set, which is this up here, what we called, we just had this lat long in the front. You tell it what the location variable is, which is the lat long. and then I tell it what the tip variable is, the tip. And then there's these other options where you can make it so it's zoomable. If you want it to be completely static or not zoomable, you can turn that off. But that's kind of the nice thing about this. You can tell it what layers you want to add. I think it actually defaults to using both of these. And then you can tell it, use a map type control. So that means that somebody could select which one of these they wanted when they're surfing around in the map. And then you plot it. That's it. Plot California Springs. And so I have that up, I think.
Do those have to be the sort of Google map types, or could you include like a local raster data set or something that you could toggle on behind your points?
I don't know if you can do raster data with this package. I haven't played around with that. You might be able to, but I'm not positive. I've only been able to do point data with this, but I don't imagine that it's not impossible to do. So what's cool is that brings up this map. So if it's not showing in the HTML, but if you basically hit print and you do this in your own computer, it's going to bring up the zoomable map. And up on the upper right, you can see I can change it to satellite if I wanted. And then you can surf around. So this is an awesome way to share data. We actually use this to share Meadows data with folks in the Forest Service and elsewhere, and basically tell them where we have sites or where we have data collection points. And then if you click on one of these, it'll bring up all that information that we just inserted. And so you can even type notes in here like, oh, this site sucks, or saw a bear here, whatever it might be. You can, right? Yes, definitely not warm. So you can play around with that as much as you like. So it's a pretty cool. I think it's a really cool interface. And then one other thing that I'll show in a second is you can add a table below of all this exact same data. So one of the other nice things is if you added, say, an ID column to this, then you could have that ID pop up in here, and somebody clicks on that and say there's an ID, they could go down and look at it, and you could add all the data in that table down below. So if you don't want to sort of crowd up your pop-up point, you can add it down here and scroll around and find it. So I will say one of the important differences between this package and the Leaflet you can actually link a table below, and maybe Michelle can talk about this below. You could say click on here, and it would actually highlight the point up in the map. In Google Maps or this Google Viz, you can't do that. They're sort of separate entities. So that is, I'm trying to think, is there anything else? Oh, so then here's the coolest thing. So it spits it out as an HTML in your own browser, right? So now if I wanted to save this and share it with somebody, if you have Dropbox or Box or any of those sort of packages or those services, you can just save this entire thing as a web page, okay? And I have in my Dropbox, I have a public folder, and it's called Google Viz within that. And I save that entire page as, here's California Springs, right? And I've saved it already. And then all you do is in that folder is you right-click and you get that public link. And then I share that link with anybody, and they can just pop that in their browser, so I can share it with any of you, and you'd be able to open this exact same map and surf around, and all the data is there. So I think that's what's really great, is you can make it basically a public website for anybody that has that link. So that's what's pretty neat about that. All right, let's go back. So I think this is probably the coolest package, and I use this one a lot to look at data because it's really quick and easy. The next couple are, so now that's the really cool one. Now we're going to go to some other just basic maps. So this is our Google Maps package. These are all static from here on out. This one's similar. So this is data of Meadows data. So I'm switching data sets on you a little bit. I apologize, but it's the same deal. This is just basically you tell it the plot on a static map. Really simple, and it's similar format. What zoom you want, the size, color of things, and you get this this really nice map. This one, I don't know that you can customize the underlying imagery that it's pulling as much, but it does make the maps pretty clean and easy. World maps. So let's back out. So I answered a question a few weeks ago on the forum. This is data that Matt Whalen had sort of asked about how you would plot on a world like globally, and so we had this fish data basically. And so this is all in here and this is on the Google forums too if you want to, or the Google group forum. So that's just the data set. And then this is the maps and ggmap package again. And maps is a nice thing because it basically, you can tell it to get a US or a world or a Europe or whatever, like a really big scale sort of map. And then once you get that map at a given zoom and a given map type, you can then go back to essentially the ggplot style of calling this, which is the same as what we had before, with the addition of, I've added a text option, so geom point and geom text, so you can actually label your points if they have a label column. And so what you end up with is this pretty cool map of, like, these are the fishing points that they're doing their work on, or where their data is from. So that's one option. And then the other one is this world map option, which is same package, same sort of format. The only difference is now it's going to be a global map. And I've added a underscore black and white, VW, takes away the grayscale, which is really nice. And then one other option is if you wanted to sort of make it wrapped, like more of a global look, you can change the coordinates of this projection to ortho, and then it makes it look like that. So that's actually viewing from the top, which is kind of nice if you have, their data set in particular is really well set up for this sort of map. So I know I went through that really fast. Are there any questions on this set?
Have you added like other cartographic elements to those maps, like a north arrow or a scale bar?
I haven't, but I think you can do that. And actually, if you save those, if you have like a JPEG or a PNG of that, I think you save it and then basically print it in here, like on top of the map. If you want to custom, because basically now that you have this, it's a ggplot figure, so you can add anything to a ggplot image that you really want, whatever that may be. So you could play around with that quite a bit, to make it look. I mean, you could make a figure that you could publish pretty easily, I think, using this option. And then one other cool thing. So now this is the Meadows data that I had mentioned earlier. I have this Z category. You could imagine this is elevation, but I'm actually using NDVI, so veg greenness essentially. And you can make a contour map of that, and then overlay your actual XY points on that. So it's using sort of whatever data it is, you can kind of see how things are distributed and what the data is that you're viewing. And this is a really easy package, Akima. And essentially, it's basically you're telling it to interpolate the X and Y's with this Z, and you want it to duplicate, because sometimes if data doesn't have if there's an NA or something like that, I think you have to filter NAs out of this actually. Yeah, NA omit. And then I had to use this strip option as well. But then after that, it's just plot your contours with whatever colors you want, and then adding the XY points. I used this parameter new true, and then just a simple plot basically, and you just plot right on top of it. And so this is kind of a cool way to look at data as well. Oh, and one more thing, setting spatial projections. I mentioned this before. So some packages require that you tell it what kind of projection you're in. Just so you know, Google is mostly requires this WGS84 in long lat. And so all this does is this is using the spatial, the SP package, to convert my lat longs, or basically add this projection. And then when you have that in that projection, that opens up a few other packages. This Dismo package provides another map similar to what we did before. But then the nice thing is the projection is really clean, so you don't get stretching and kind of other things like that. So that's pretty much the same option as before, but I basically made it this Mercator projection from the XY points and plotted that. So that's all I've got. Those are just a whole bunch of methods to throw at you to play around with. But hopefully there's enough code and you can use your own XY data to plot stuff. So any questions? Yeah.
You would choose like selecting the base map.
Mm-hmm.
So XY data, like the center of that map, and the bottom left corner.
whatever you want it to be. You can even do, so let's go up to one of the places where you tell it. So the world maps are plotting, but this is a good one actually. So this is like centering on the whole US, but like this one, plot on a static map, it's actually reading the extent of your data in this case. So you don't even need to specify, it just knows like, boom, I'm gonna center that, which is nice for the static map. For the other ones up higher, I did set centering, and for that, you can, yeah, so here you go. What you could do is take like a mean of your lat or your long, or a range or max or min. You can play around with it, but yeah, you do need to sort of specify. It does, I think there's another option in here. You can set a bounding box. So if you know sort of you can figure that out, you can do that as well. I just centered it right there, but yeah, you can do that. Yeah. This is the Meadows. So this is a Meadows data set. So it's just XY Meadows. Yeah, so this is kind of weird. This is actually the Modoc Plateau up here, and this is the Northern Sierras. So this is probably the Feather drainage, and then maybe Shasta is up here. The contours are generated from this NDVI, so this veg greenness. So it's actually just saying the highest greenness is in these green regions, right? And then the lowest, so the driest areas, which makes sense because the Modoc Plateau is definitely much drier compared to the Northern Sierra, is down in this area. Correct. It's using, well, so it's using the lat long point to sort of spatially draw that. But yes, that's only showing basically the surface of NDVI across this data set. Definitely, yeah. That would make much more sense probably than what I did. But well, I did that on purpose. The terrain color is always the highest, is usually green, so I sort of figured green to dry would be better. Cool. All right. How do we switch over here? Stop.
So just give us a minute while to switch the. Oh, we'll back up.
Okay. I'm done.
Yeah. So you can just grab the cable. Yeah. And you just hit that screen share button on the top left. No, down. The green, the screen with the arrow. Yeah. That's good. Okay, and I will switch to you.
Yeah, if you switch out of that window.
Oh, I see.
I think.
Switching again.
Yes.
Got it. Okay. All right.
Is on.
All right.
You can just pipe audio through my machine.
That's true. I think you're muted though.
Okay.
That's in the Hangout is where you're muted.
Oh. Lord.
No, doesn't say you are.
But look at the speaker on the bottom. I'd open mine up. On the bottom right. There you go. That might work now.
All right. Is it getting my sound or? Now my speakers are playing the sound from the room. Sorry. All right. Excellent.
Right.
All right. Okay. We should be good to go now.
Should I mute my
Yeah. Mute
speakers?
yours. Yeah. There we go.
Sorry. Lenovo has like 3 different sets of controls for everything, and so sometimes you can't get it to behave. All right, let's try this. All right. Projecting, it looks like it's up on the screen. Okay, we're good. So, like Noam said, my name is Michele Tobias, and I work at ICE, but I also work at Geospatial Consulting, which is a consulting group on campus that does geospatial work like mapping or spatial analysis for students, faculty, affiliates, and also off-campus people. And we have the university assigned us a rate, so we have an hourly rate, but it's actually pretty competitive, if not lower than most consulting groups around. So if you're interested, contact me. There is, well, you can find me, Google search, probably pretty easy. So I'm going to tell you today about making maps with a package for R called Leaflet R. It's pretty straightforward, so this probably won't take that long, but let's just get into it. So this package it's one of the packages out there that lets you do something else through R. And the something else in this case happens to be Leaflet. Leaflet's a JavaScript library which is used to make web pages, specifically web maps, that are interactive. So I can show you, hopefully this will work, show you an example of a leaflet map that I've been working on. Here we go. So this is a part of a larger web page, but what it actually shows is I have shapefiles of historic beach plant data from published literature. So there's 3 points in time. There's 1936, 1974, and then 2012, which is actually data from my dissertation. And so you have a map, and you can see that there's points on there. It can do pop-ups. I think this one will pop up. Oh, maybe not on that map. No, mine will work. So if you click on a site, this time it has a little pop-up tool that tells you what beach you're at. I've also linked it, so if I change either zoom level or if I can, all of them go, which is nice because if you're trying to compare across different species, you can have it do it automatically. So also if I zoom out, they'll all zoom in or out. Yeah, so this is the base map on there is watercolor tiles from Stamen. So they're freely available. You can swap these into your web maps. Obviously, it's not the most technical kind of thing, but it looks really nice, so that's my default. But I can also switch it to OpenStreetMap. Right now, they don't all switch when you switch base layers, but maybe I'll get there. And you can also change what species you're looking at in these maps as well. So this is just one example of how you can use Leaflet. And this map was programmed all in Leaflet, but the thing I'm going to show you today kind of helps you get over the hurdle of learning Leaflet. So it's kind of fun. So this is, like I said, this is just an example of what you can do with Leaflet. And this is online, so if you're interested, look me up on GitHub, and it's hosted on GitHub. So it's actually a published map that's running. Okay, so that's sort of a very brief intro into Leaflet. Basically, it's just some JavaScript library you can use in conjunction with HTML coding to make a web map. Don't worry, I'll give you links for how to learn all of that kind of stuff too. So this is a lot that goes into these things. So Leaflet R is a package specifically for R, and it allows you to enter commands into your R terminal, and it actually generates Leaflet JavaScript commands for you. So in theory, you don't have to learn how to program in JavaScript or using the Leaflet libraries yourself. You can use R, which is more familiar to people in this room, to generate some basic maps for you. So that's pretty awesome, and I kind of wish I had known about that when I first started working with Leaflet, because it really does get you over the hurdle. And so the output that you get after you run these commands is an HTML document. So it makes a new text file that has HTML and JavaScript in it. And then you can view it in a web browser. And in theory, you could also eventually upload this to the web and have a running web page that looks like your map. So here's some pretty simple code. This is all you need to make a map to start with Leaflet R. Pretty simple. You load the library, and then you run the Leaflet command, and then you call it, and poof, you get a map. So let's switch over to R. In spite of my tech issues today, we're going to try this live and see if it works. Should already be loaded. All right, so we've loaded the library. We are going to call the Leaflet command, and then we can just run that. Running live, woohoo, ta-da! So this is the most basic map. This should look familiar. This is actually OpenStreetMap data that it's grabbed, you can tell, because it says in the corner down here it has the OpenStreetMap attribution, so it does that automatically. And then you get a map of the whole globe stretched out in web Mercator projection. So really simple to get started. And then if you wanted to look under the hood, I think I've got it on this side. Not that one, this one. So over on the side here, I have the code that it spits out. So if you're familiar with HTML documents, this looks pretty normal. If you're not, it just looks like a bunch of gunk that you don't have to write now because it already did it for you. And then the JavaScript, the actual Leaflet code is happening in this sort of grayish, bluish box here. So the nice thing is, if you wanted to learn Leaflet and you wanted to learn how to make web maps, you can actually use this R package to set up the sort of basic map for you. And if you're like me, you work on examples and you don't really want to start from scratch, so having it already done and you can look at it and see what's happening and modify also what you've got to start is really nice. So really, really simple to get started with this. Customizing it is a little more complicated, but at least you got your map made in like 2 seconds, so yay for accomplishments. Okay, so I have a more complex example in R. Let's hope my tech problems have turned themselves around. So this isn't too complex, but it's a little bit more than what we did before. So this is mainly coming out of the documentation for the package. They have a really good set of documentation and good examples. So I just kind of grabbed their stuff and added in a few things. But so this works with the Quakes data set that's available through R. So we're just going to load the Quakes data and take a look at it. So you can see that the data set comes with a latitude column and a longitude column. It also gives you some attribute information, like you get the depth, the magnitude, and then a station number for each of the events. So really similar data to what we saw previously. The key is that latitude and longitude column. Now, so the next line we're going to run generates the data. So you can't just run the data as is in a data frame. It needs to be converted to a file format called GeoJSON. But our Leaflet package, or Leaflet R package, includes code to switch from just straight lat long to GeoJSON. And if you open up, once you make a GeoJSON file, you save it, and you look inside, it's actually really readable. It looks kind of like what you would expect a shapefile to look like, just a table with attribute information. But it's formatted in a way that works really well with web mapping technologies. So we can also look at the properties of this GeoJSON file. There's the get properties command. And basically it reads back to you the attribute columns that if you were working with a shapefile, you'd expect this to be sort of the headings in your attribute table. So this is expected. It's telling us we have columns for depth, magnitude, and the station number, which we saw in the original data. So that's nice. We know it's all in there. Then we need to make a style for map. So now that we know what's in there, this line just kind of tells it what the point should look like in the final map, and we'll see what that looks like in a minute. So, and then we are going to create our map file. So I told it where to save it in a separate line, and then we run this q.map with a bunch, or sorry, the Leaflet command assigned to a variable. And we pass it a whole bunch of arguments, which should look familiar, like here's our data. in this one. The save file is the line just above, so it's telling it where to put it. The default in the code that I grabbed was for a temporary directory, but I want to go find it. And then I got the title for the map, so we're calling this Fiji earthquakes. The base map in this case is coming from this particular place. I don't see it in there, so maybe this is sort of one of the arguments. Our style file is being called right there, and then we have also a section for pop-up. So the next thing we just need to do is call our map. And there you go. So I mean, this is a nice example that works really well. Obviously, when you try to swap in your own data, there's going to be some issues. As I've seen, I've broken my online map so many times. But it's kind of nice to get this going and have some success and see that it actually works. And you can actually open up, let's see if I can find it. You can actually open up the HTML document. If it's going to go. Should I open this earlier? Oh, made its own folder. There we go. So we can open up the HTML document that the commands generated, and we can see it looks, the top looks really similar to that really simple one, which, you know, it's an HTML document. We'd expect that. It's got some style stuff in there. And then here in this blue area is where the JavaScript is running. So you can look through this, and in conjunction with some other tools that can help you get going, you can kind of start identifying where all these commands come from. And if you wanted to, you can actually edit this JavaScript section to change up the way it looks, to add in the data. You can actually switch the base layers and things like that if you wanted to. Yeah. Yep, exactly. Yeah, in some ways it's really complicated, other ways it's really simple. So yeah, if you wanted to change this, you could just change it, save it, and then reload the document in the web browser. That's the easy part. Now breaking the map is a little bit more complicated, I say from experience. Right. So the data types, again, that this takes is, it can accept GeoJSON data and then TopoJSON. I'm less familiar with what TopoJSON looks like, but you can probably find that online pretty quickly. And again, there's conversion tools, so you don't even need to know what GeoJSON is. You just need to know what it requires. In this case, just latitude and longitude, and then any attributes you want to give it as well. So it's pretty straightforward to get started with that. It's also nice to know that R can generate GeoJSON, so if you didn't want to do it through another tool, then R can actually do that for you. So a couple concerns about using this particular package for mapping. So first off, its default projection for Leaflet is Web Mercator. And that's okay. Everything that goes, you can see, like, if you look at the world map, obviously there's places with distortion. So if you wanted to use this for different kinds of maps, you might want to change the projection. So definitely pay attention to that. Also, one thing I ran into was to make sure that every layer that you're trying to put into your map needs to be in the same projection as the base layers and all of the things that the map is expecting. Otherwise, it just doesn't show up. So I spent a couple hours yelling at my computer, why won't my data show up? And it was because it was a wrong projection, like rookie mistake, but it happened. Yeah, Nate?
So in the, is it automatically handling the latitude and longitude to Web Mercator translation?
I think so, yeah. So everything goes in as lat long, but then it's projecting it to Web Mercator, I believe.
Yeah.
Yeah.
I have run into issues with that where you sort of need to check your data. So I think knowing that if it plots in one of these other methods that I showed earlier, it should plot in what you showed.
Yeah.
And if it doesn't, then you need to figure out what's happening.
Yeah.
Because I've put in that state.
Yeah, and it's kind of frustrating if you don't get an error message, it just doesn't show up. So it's like, you know, why can't I go off if I don't get an error message? It's just broken. So, yeah, definitely projections are important, I think, for all of these kinds of things. Know what you're working in. Also, this particular package isn't really designed for print maps. So I wouldn't use this to generate figures like for a publication or something like that. It's not really designed for that. Another thing to pay attention to is the terms of service. So you can pull in all kinds of different base maps. Like I showed you, I've got on my online map, I have the statement tiles, and then I have OpenStreetMap. So if you're going to use those, just make sure that you understand what the terms of service are, so you're not violating the rules. Most of them have pretty open licenses, but you want to make sure that you're not using it in a way. Just because it's free doesn't mean you can do whatever you want with it necessarily. So check those. You definitely don't want to put something out there and have it, not be the correct usage of the product. The same thing if you are going to use it for print maps, which obviously I don't think is a great idea, but there's different things that you have to do if you're going to use those tiles in a print map. So make sure you understand that too. All right, so a couple things that will help you get going with this. The documentation for Leaflet R is really nicely done and it's really straightforward, which I know you probably have seen is not always the case with every R package out there. So definitely check that out. It's nice and simple. It's actually not a whole lot of commands available, but that kind of makes it manageable. If you're interested in going further with it and you want to work with the HTML and JavaScript output, I highly recommend a website called W3 Schools. They have tutorials and learning tools and also a really nice set of documentation for HTML and JavaScript, as well as a lot of other things like SQL, so check that out. And then if you want to work specifically with Leaflet, the Leaflet website, it has some good examples. I think once you've seen a file generated for you, it'll be a little bit easier to work with their examples. They assume you have web programming skills, which I didn't to start with, so it was a little bit of a hurdle to get past that. So if you wanted to modify the output of Leaflet R commands, then you could use the Leaflet documentation to kind of work with that. Also, a package to look at if you want as well. There's Leaflet for R is another package that's available. It's a little bit more complicated, but it's also available to use. So I recommend looking at that. Let me show you a couple more things. Okay, so here's the documentation for Leaflet R. You can see, okay, there's the whole list of things that it has. So it's pretty short, pretty sweet, which is nice for getting going. I think it's a really good place to get started if you wanted to work with web mapping and Leaflet. Here's W3 Schools. So you can see they've got a lot of stuff on here. So if you're interested in learning more than even just HTML, there's other things on here. I've worked a lot with like the SQL and the CSS stuff, and I think it's pretty well done. So I recommend that for learning a little bit further outside of R. And here's the Leaflet page. So they have nice things in here, like working with the custom markers. So if you wanted to put those pop-up balloons when you click, there's examples for how to do that. You can have all kinds of different examples for like how to make chloropleth maps, so changing the styling. Working with layer groups, which you've seen in the map that I showed you. You can actually group things up and give people options. So it's not just one list of things that they can turn on willy-nilly. You kind of group things, and they have options within that. So this page is really helpful for styling with your map. So if you wanted to add things in, this would be a good place to look for some of those extras. Oh, here's the Leaflet R. They have a really nice tutorial. I wasn't able to get too far with it, so I switched to the other package, but it's really well documented, and it's got nice step-by-step instructions with examples of what your output should look like, so that's really helpful. It's always a challenge if you don't know what the output should look like when you've done it correctly. So that's nice for learning. Another thing to look at if you're interested in doing web mapping or even just mapping in general, MapTime is a group. I'm not a part of it, but it's really cool because it's basically you get together with people and you work on maps, kind of like the Davis Art Users Group, but for maps. There's a chapter now in Sacramento. They only have a Twitter page right now. They don't have a separate web page, but you can check that out. So if you're interested in learning how to map and you want some more time with people to help, MapTime is a really good option.
If you have to do that.
Yeah. Okay, excellent. Yeah, they like rainbows and those would be stickers. So. It's a cool group. It really is, and it's new to our area. So if you're interested, definitely go to the map time meetings because that way it'll stick around. So I think that's all I've got for this. So are there any questions or comments or? Yeah.
So you mentioned the default projection is here.
Mm-hmm.
Did you say it's possible to change that?
It is with Leaflet. I haven't tried it, but I've heard that it is possible. So.
Does that mean that the base maps have alternate projections?
No. Yeah, so you would have to provide your own tiles in that case. So that's one reason not to change it. And for a web interface like this, it's fine. We're not doing any measurements on this. We're not, displaying anything that really matters if things are distorted a little bit. But yeah, if you wanted to change the projection, you'd have to make your own tiles or background layers to work with. Yeah. Any other questions? All right, cool. Thanks.
Thank you.
Thank you.
And like always, we'll have all of this stuff on our user page over the course of the next day or so. I'll get it all up there. Links to Brian and Michelle's code and everything else they showed up here. So I'll send that around.